Welcome to Top Acad. In the last video, we saw that if we have something like a plus b to the power 4, we could use the Pascal triangle like 1, 1, 1, 2, 1, 1, 3, 3, 1. This was a plus b to the power 1, a plus b to the power 2, a plus b to the power 3, a plus b to the power 4. 1, 4, 6, 4, 1. These are the coefficients of the terms of the binomial expansion. If you know how to do this, you can refer to my previous video using Pascal's triangle. So suppose we want to expand a plus b to the power 10. How do we do it? In this case, if we use Pascal triangle, we have to sit and calculate a plus b to the power 5, coefficients for a plus b to the power 5. You have to find the 6th row, 7th row, 8th row, 9th row and 10th row. Oh my god, that's a lot of calculation. Is there a simpler way to do this? There is one. So let's see what that is. So if you see here, 1, 1 can be represented as 1C0 and 1C1. This will give the value 1 and 1. And 1, 2, 1 can be represented as 2C0, 2C1 and 2C2. So do you see a pattern here? It's so much more easier. 3C0 is nothing but 1. 3C1 is nothing but 3. 3C2 is again 3. 3C3 is 1. Okay, so if you don't know what is this 3C1, 3C1 can also be written as this. It's nothing but 3 factorial divided by 3 minus 1 factorial into 1 factorial. You can watch my combinations video to understand how to do this. So this will become 3 factorial divided by 2 factorial into 1 factorial, which is 3 into 2 factorial divided by 2 factorial. It's 3. So 3C1 is nothing but 3. Okay. So if you calculate all of this value, you will get the values in the Pascal triangle. So now, can we do a plus b to the power 10? Yes, we can. We can say that the coefficients are 10C0, 10C1, 10C2, 10C3 and it goes up until 10C10. That's it. So let's see if we can write this. I will not write all the terms because when you have like a plus b to the power n, there are n plus 1 terms. In this case, there will be 11 terms. I won't be writing all the terms, but let me write the first few terms using this expansion. It is 10C0 into a to the power 10, b to the power 0, plus 10C1, because b to the power 0 is 1, 10C0 is also 1. This will become a to the power 10. 10C0, a to the power 9, b to the power 1, plus 10C2, a to the power 8, b square, plus 10C3, a to the power 7, b cube, plus, I'll write the last one, 10C10, a to the power 0, b to the power 10. Okay, if you see that this value and this value are same, 2, 2, 3, 3, 0, 0. Okay, so let's generalize this and write it for a plus b to the power n. It will become nc0. Okay, it starts from nc0, a to the power n, b to the power 0, plus nc1 into a to the power n minus 1, because it keeps decreasing, remember, and b to the power 1, plus nc2, a to the power n minus 2, b to the power 2, plus it goes on and it becomes ncn, a to the power, you can say n minus n. A to the power 0 is nothing but a to the power n minus n, b to the power n. I'll tell you why I wrote it like this. You see that 0 and the power of b is the same. Here 1 and here the 1 are the same. Similarly 2 n minus 2 are the same. So these are same. So if you want to generalize this, how do we do it? So a plus b to the power n, let's shorten it. If you want to shorten it, you can write this as plus b to the power n is equal to summation of, this is all summation, this is all, you get this by adding all the terms, right? Summation of, let's call this variable 0, 1, 2 as r. R equal to 0, 2, it goes up to n, okay? And NCR, see, this is NCR, a to the power n minus r. See, this is r. So we call this r. So this becomes n minus r, b to the power r. So this is the formula which we can use to expand binomial raised to any power. Okay. So this works when n is a positive number. So you have to remember that when n is a positive number, like n is 1, 2, 3, 4, it can go up to any number. So I'll show you a few problems so that you'll understand this better. Next, what is a general term? Okay, so we saw that a plus b to the power n, the binomial theorem says a plus b to the power n is equal to r to the power 0 to the n, ncr, a to the power n minus r, b to the power r, right? So general term. So if you want to find a particular term in this expansion, how do we do it? You can say, like, any term is a to the power n minus r, b to the power r. So this is equal to some term. But what term is that? So when r is equal to 0, because it starts from r equal to 0, you get the term 1, right? So when r is equal to 1, you get term 2. When r is equal to 2, you get term 3. So we can generalize this and say t r plus 1, 2 plus 1, or r plus 1, you will get the, so this will give you any term that you want in a binomial expansion. So let's see few problems to understand this better. Write down the first 4 terms in ascending powers of x. 1 plus x to the power 10. We want to expand it. So how do we do that? We know that a plus b to the power 10 is equal to sigma r is equal to 0 to, to the power n. Let me use the generic formula. To the power n, ncr, a to the power n minus r, b to the power r. So here in this, a is equal to 1, b is equal to x, n is equal to 10. Let's replace this in this formula. 1 plus x to the power 10, and we want only 4 terms. Okay, let's do it for 4 terms. Once 10c0, n is 10, 1 to the power 10 minus 0, b to the power 0, plus 10c, it's not b, it's x to the power 0, because b is x. 10c1 into 1 to the power 10 minus 1, x to the power 1, plus 10c2 into 1 to the power 10 minus 2, x square, plus 10c3, 1 to the power 10 minus 3, x cube. So let's find the value. So we always know that the first term is a to the power 10. So we can say 1 to the power 10, which is 1 here in this case. It's 1 to the power 10 because this is 1, this is 1. So this is 1 to the power 10, which is 1, plus 10c1. So nc1 is always equal to n. So we know that this is 10. 10 into 1 is 1 to the 1 raised to any power is 1, and then we have x to the power 1, 10x, plus what is 10c2? Let's calculate 10c2. 10c2 is equal to 10 factorial divided by 10 minus 2 factorial, which is 8 factorial into 2 factorial. This becomes 10 into 9 into 8 factorial divided by 8 factorial into 2 into 1. So this becomes 45. 45, 1 raised to any power is 1, x square, plus let's do 10c3. 10c3 is 10 factorial divided by 10 minus 3 is 7. 7 factorial into 3 factorial. This is 10 into 9 into 8 into 7 factorial divided by 7 factorial into 3 into 2 into 1. 3 factorial is 3 into 2 into 1. 3 3s are 9, 2 4s are 8, 4 3s are 12, so it is 120. Let me erase this. It's 120 x cube, plus you write dash 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 because this is not the complete expansion of 1 plus x whole to the power 10. We'll have more terms coming. That's what we show by putting the plus sign and dash dash. Okay, so we found the first 4 terms, term 1, 2, 3 and 4 in ascending powers of x because it is 1 and it's ascending to 2, 3. That's what is meant by ascending powers of x. So this is the answer to this problem. Okay, next one. Without simplifying, write the 6th term in the expansion of 3x minus 2 by x square whole to the power 12. Okay, we want to find the sixth term, which means we want to find T6. Let's see what values we have. We have A is equal to 3x, B is equal to, remember, take this sign, minus 2 by x square. It's not plus 2 by x square because there's a negative sign here. And N is equal to 12. And what about R? So we know that TR plus 1 is equal to T6, which means R plus 1 is equal to 6, R is equal to 6 minus 1, R is equal to 5. Okay, so we have all the values here. Let's find T6. T6 is equal to NCR into A to the power N minus R, B to the power R. Let's write it as TR plus 1. So now T6 is equal to, what is N? 12C 5. What is A? 3x to the power 12 minus 5 minus 2 by x square to the power 5. So they don't want us to simplify it. So we're not going to simplify, but just write the correct powers. 3x to the power 7 and minus 2 by x square to the power 5. This is the answer. This is the sixth term. We don't have to expand it because they're saying without simplifying. Then there is no need to simplify this. Okay, this is the sixth term of the expansion of this binomial. I hope you understood how to do binomial expansion using binomial theorem. In the next video, I'll do few more problems to find the constant term and the coefficient in the term of a binomial expansion. Thank you.